Cover lines and slope. It's class 14. Don't forget on Wednesday you have quiz number 2, which will be on classes 9, 10, 12, and 13. So it covers class 13 that we had on Friday. If you need or want more time to take a quiz on Wednesday, please come to class early. You will have 20 minutes to take the quiz. So if you think you need more than that, you're welcome to come at 10 o'clock. Just come and get me in the studio and I can give you the quiz. I want to remind you that your homework that you had on modeling on piecewise functions was a little enabling in the sense that you didn't actually have to graph these functions. They had the graphs for you and you just had to pick the right one. So I would make sure before Wednesday's quiz that if you have a piecewise function like this, that you could graph it on your own. So you want to go through and look at a couple of the homeworks that you had and make sure that you could graph these on your own. Or make sure you do these 4 problems from your class 13. Now, once you do these 4 problems from your handout, modeling piecewise functions, I will give you the answer key. Now, you don't have to get them all correct. I just want to see that you've made an attempt to think about this, and then I will hand you the answer key, because the last one's a little more interesting, right? They get more interesting as you work through these problems. Brittany?
So to graph them,
yeah.
Just plug it into like the line.
Well, if it's a straight line, yeah. If it's a remember like we did in class the other day, we graphed the parabola and then we erased part of it and then we did the line, yeah. So some of them might just be constants, right? Which are horizontal lines like, y equals 3 or 4. Some of them might be little like 4x's like we just saw a minute ago. I think I closed out of it. Let's see if it's still there. So like this one, this is a parabola, right? So you're going to be looking for like, it won't be one of these because it's parabola roping upward because this is positive. And then this is going to be a straight line. So it's got to be one of these two. Okay. And and they didn't finish drawing all this for you, but this straight line would have to go through 0, -3. So then you got to look and see which one will go through 0, -3. But if you were graphing this, I would expect to see like a straight line either going like this or like this, depending on which one of these is the correct one. Now, right away, it can't be this one because your slope is positive, right? So you would just need to know how to graph pieces of each of these, yeah. Which you will know how to do. I won't give you anything that's going to be like crazy, like cubics or anything like that. All right, so let's start today. I think for many of you, this is going to be like a pretty fast review. So what I'd like you to do right now is I'd like you to read the definition of slope. Some of you may have your favorite way of remembering it. There's 3 different ways here to look at slope. And then I'd like you to find the slope of the 4 graphs that you have directly below this. Okay, and put up your flag when everyone at your table is done. And I'll come around and check out how you're doing. Look at these problems here. Now, I would always suggest when you're finding the slope, if you have a little piece of graph paper conveniently nearby, even if you don't, you could just plot the points real quickly. And connect them so that before you even do your calculations, you'll know whether your slope is positive or negative, right? So it's always a good idea just to do a little quick sketch, and then you'll have the information in case you make an arithmetic mistake. So let's see. I think if we take the first one, the slope here, it never matters which of these 2 points you call x1, y1, x2, y2. It's totally up to you. Okay, so we're going to subtract look at the difference in our y values. Now, the only thing that's important is if you say that this point right here, -4, -2, if you're calling -2 y2, then its partner, -4, has to go directly below it. That's the thing that matters, x2 minus x1. And those have to be in exactly the same order as what you have above. So let's see, we get here -2 take away 4 over -4 take away a -3. which is -6 over -1, which is 6. So our slope for the first line is 6. Anybody have a question on that? 6? The other thing you could do is if you actually plotted it, you could walk from one point to the other. So if you were, say, let's call this point A and this point B, and if you were walking from point A to point B, you would go to the right 1 unit and up 6 units. There's your slope, 6 to 1. Or if you walked from B to A, you would go to the left 1 unit and down 6 units. There's your -6 to 1, -1 for 6, a slope of 6. So it doesn't matter how you walk. This one says walk 1 step to the right and up 6. This one says walk 1 step to the left and down 6. It just depends on which way you're walking on your number line. On your line, excuse me. Well, how did you get 6 over -1? Hang on. Hang on. 4 take away -2, yeah. Yeah. And what's 4 take away -2, Jonah? And what's -3 take away -4? -3 plus 4. 3 negatives and 4 positives. Okay. All right, so you answered your own question there. That's good. That's the best way to figure it out. Now the next one, again, I just plotted the points that I had really quickly. I look at my line, I know it's negative. And again, I could walk from, let's say I'm walking from point A to point B. I would go down 7, that's -7, into the right 5. So there's my slope, -7/5. That is exactly the same as 7 divided by -5, because now I would decide to take my walk going backwards from B to A. I'd go up 7 and to the left 5. So there's the up 7 and to the left 5 right here. Okay, so those two slopes, any questions on those? Okay, so often it's these last two types of lines, a horizontal line and a vertical line, that most students have questions on. And if you think about walking along this line, depending on if you're injured, lazy, or just not in shape, this is the kind of hike you want to do, right? No rise at all. You're just kind of walking a nice straight line or biking a nice straight line, right? There's no rise. That means all of the change in your y values, since all your y values are exactly the same here, your y values are zero. The change in your y values is 0, and it doesn't matter what the change in your x values are, because once you get that 0 in the numerator, your slope is 0. So that a horizontal line, it makes sense. There's no, the slope is 0. It means that I'm not rising at all as I walk along horizontally. The vertical line, it's impossible to get a slope for. Here you have all your x's the same. So this point would be 3, 5. And let's pick any other point, -4, 3, -4. Sorry. This should be -3, 5, and this should be -3, -4. So any point along this line, all your x's are the same. So when you try to use your slope formula, you'll get some change in your y's, but then when you get your change in the x's, it will say there isn't any change in my x's, and there's no such number that defines that slope. So we can say that the slope of a vertical line is either has an undefined slope or no slope. Okay, no is different than 0. 0 is a perfectly good number here. Okay, so you can fill this last part out yourself right here on your own. William? Yeah, I mean, you know, it's hard getting into the semantics. No slope to me means that there's no number that defines the slope. A 0 slope says I can walk along, but I'm having literally zero rise.
Right.
So
Okay.
that's how I think of the difference. And to avoid that, some students just don't even deal with the zero and the no, they just put undefined. And that seems to be easier because that's what we learn when we try to do this division. But it's important that you don't say that a horizontal line has no slope, it has zero slope. And it's hard because we often will say zero and no are sort of similar things. So it's a little bit, that's where it's kind of like everyday usage of English and math can get a little tricky. Okay, so these are the four possibilities for the slope of a line. We just looked at all four of them, okay? And my question here is, which of these four graphs that you're looking at does not represent a function? Which of these four graphs does not represent? Yeah, Gina? The undefined slope. So the vertical line, right? This is not a function. Because if we tried to use the vertical line test here and we put a vertical line straight down through that vertical line, we're going to touch it in a heck of a lot more than 2 points, right? 3 points, 4 points. Well, it's infinite number of points it would coincide with. So a vertical line is not a function, but all other forms of a line would be examples of linear functions. All right. Now we're about to explore in the next 20 minutes 3 forms of a line, 3 equations for a line. Okay? So one of the equations we're going to look at for a line looks like this. And it's called the point slope form of a line. The other form equation for the other equation we're going to look at is called the slope intercept form of a line. And this is the form that most of you come out of high school knowing the best, or at least you can say what this equation looks like most often. If I ask you what slope intercept form of a line is, what would you tell me? Y equals mx plus b, right? That's what most of you are most familiar with. But it's not the only one. You have more tricks in your bag than y equals mx plus b. And then the final form of a line is the general form of a line. Ax plus by plus c equals 0. This is called the general form of a line. As opposed to the kernel, right? I wonder what the kernel would do here. Probably have something in the denominator that it can rule over, right? Oh, no, the general's higher than the kernel, though. Yeah. Okay, so all 3 of these forms of a line have their pros and cons. And so part of being math literate is that you have, of course, accuracy, that you can do a problem correctly, but that you have flexibility and efficiency. So sometimes it's more efficient to use one of these equations over another, depending on what you're being asked to do. So I want to try to show you some of those efficiencies today. And I want you to be able to move between these two fluently. Okay, so let's take a look at this first form here, the point slope form. So before we get on to anything, let's remember this is an important idea here, and we actually talked about this the other day in class, that what makes a straight line straight is that the slope is constant. It has the same slope no matter what 2 points you walk between on your line. Okay, it has a constant rate of change between any 2 points on the line. That's what makes it straight versus curvy. When you have a curve, you don't have that feature where you have this constant rate of change. So if I choose my 2 points on my line and I use one point that's fixed or specific, in other words, I know what the coordinates are, I'm going to call that x1, y1. And because I want to come up with an equation, I'm going to keep my other form of my line as an arbitrary point or a generic point called xy, not a specific point. Then you can use the same formula for your slope to come up with this equation called the point slope. So you're used to seeing something here like y2 take away y1 divided by x2 take away x1. The only difference is we're just going to call it y take away y1 and x take away x1. So we say that this equation is solved for the slope, right? That's what we say. This equation, this particular equation, this equation is solved for the slope because the slope is isolated, right? It's on one side of the equation. So and we're familiar with this equation. So a lot of people, I say to students, it's not like you're learning a new equation. You really know this equation. It's just disguised a little bit. So if I now take this equation, and remember, this is just a division problem. If I make this into 12 divided by 2 equals 6, do you agree that this equation is the same thing as 6 times 2 equals 12? Do you agree with that? Right? The answer times the divisor is what you started off with, right? So that's the same thing that I'm going to do now. I'm just going to, because this is really a proportion and your cross products are equal. It's just that we could put that as a 1 there. So I could say m times this, m times the change in my x's is equal to my numerator. There we go. So this is the point slope form of a line. Okay. Point slope form. Do you see why we call it the point slope form? Does anybody see why we call it point slope?
Use a point on the line.
Okay, so we have to use a point on the line and we have to use the slope. Okay, sometimes we might have to find the slope, right? It may not be given to us. Okay, so we see we have the slope right here and a specific point. And that's all you have to do. You just got to plug in those 3 values and you don't have to do anything else. You don't have to simplify it. You don't have to solve it for y. That's all you have to do. So let's take a look at how we would do this first problem right here. Write an equation. Notice it says write an equation in point slope form that meets the following conditions. Then solve the equation for y. So when you solve the equation for y, you're putting it into the y equals mx plus b form. So you're going to actually do both forms right now. So we're going to do point slope first. So you say, okay, point slope is just a variation of my slope formula where I'm solving for my change in y. That's all I'm doing. Y and x are generic. And then I have a specific point, x1, y1. So now all I have to do is plug in 6 for my slope, 6 where I see my slope. I'll never have y and x a value for y and x because that's an arbitrary point. We want to keep it as variable. But we do have to have one other bit of information. Even if I know the slope, I can't write my equation without knowing one point on the line. So I'm given that right here. Here's x1 and here's y1. So where I see y1, I replace it with a -5. And where I see x1, I replace it with a 2. So right now, in this subtraction form, you know something about this line. I mean, you know it because I wrote it out. But let's suppose I took this out, this English out, and I gave you this on a test. And I said, give me a point on this line. Well, all you have to do is say, oh, 2, because that's x take away x1. So x1 is 2. And y take away y1 is -5. So 2, -5 is on this line. But sometimes it gets a little disguised when you simplify it. You see, it looks like this. So here you got to be a little clever. You say x is going to be 2 and my y is -5 because I know my formula has a subtraction in it. So for this to become a +5, I must have been subtracting a -5. So this is, you're done. Boom. There's your point slope formula. All right. So if you tend to lose points because you add and subtract wrong, this is the golden form for you, right? It's done. I'm not asking you to do anything else. The next part says solve this equation for y, means put it in the slope-intercept form. Now you have to use your distributive property on the right side and subtract 5 from both sides, and you get your slope-intercept form. So here's your point slope, and here's your slope-intercept. And the reason why they call it slope-intercept, why? Why do they call it slope-intercept? Someone other than William want to help me, Chris? All right, this is your slope just like we had before. And this value, the negative 17, is your y-intercept. X is 0, y is negative 17. So what information can you get when you look at this? You still get the slope and you get a point. Just like up here, I can look here and say my point is 2, negative 5. Here I say my point is 0, negative 17. So the point that you know from this one is the y-intercept. So it's a very specific point that is often helpful for us is the y-intercept. Okay. So what I'd like you to do is at your seats, I'd like you to work on part B. And what do we have to do in part B we didn't have to do in part A? Yeah, we want to do the point one, but we have to do something. This one gave us a little freebie that this one doesn't give us. Slope, right? This one gave us a slope here. We got to find the slope first. So we got to find the slope first. That's our first step, and we're not going to get anywhere. And then we use one of these points in this formula. So you try that and check it with your table or check it with me, however you'd like to check. The first thing we have to do is we have to find the slope of the line that passes through these 2 points. So this is just something I always do. Even though I feel really confident in my mathematics, in my arithmetic especially, I always on the side of my paper just do a little thing like this. Whoops. Yeah, that's really good, Linda. I didn't even plot the point, right? Let's see. I'll go over a little bit further. So I go -2, -1, -1, -6 like that. And then I connect the 2 points just so I know before I do my math whether my slope is positive or negative. It's just like a little internal check. Or I visualize where the 2 points are and if I don't draw them. So I know before I even start that my slope is negative, just in case I make an arithmetic mistake. Okay, so we have the change in our y values, -1 take away a -6, -2 take away a -1, and that gives us -1 plus 6 in the numerator and -2 plus 1. So that gives us 5 in the top and -1 in the bottom. So my slope is -5. So now I can turn this question into a question just like this. Find the equation of a line that has a slope of -5 and passes through. Well, now you have your choice, this point or the other point. So I say, okay, as long as I know my slope and a point, I can use my point slope form. And it's really up to you which point you use. In the end, you'll get exactly the same equation. So I do y take away a -1. I'm going to use my first point here, equals -5 times x minus a -2. Y plus 1 equals -5 times x plus 2. Voila, you are done. That's all you have to do. You just plug it in, the point and the slope. Now, to solve for y, you have to do a little work. To solve for y, you have to use your distributive property on the right-hand side and solve the equation for y by subtracting 1 from both sides. And now you have your your slope-intercept form. Here's your slope and your intercept. So you know this goes through the point 0, -11. When x is 0, your y value is -11, and your slope is -5. Okay, any questions on that? Getting either of those equations? Anybody? I see people writing, so does that mean you had a question? You couldn't do it? Or, oh, x and y is backwards? Yep. use the other point. It doesn't matter in the end. You still should get y equals negative 5x minus 11. Did you, Cambry? Yeah, let's try. Well, let's try the other point. Tell me the other point so I can put it in. Okay, so y is negative 6 and x is negative 1. Okay. So we get y plus 6 equals negative 5 times x plus 1. Y plus 6 equals negative 5x minus 5. And y equals negative 5x minus 11. So in the end, regardless of which point you use, you get exactly the same line because they're all equivalent equations. They're all the same equation, just in a different form. Okay. All right. So you're going to have a lot of practice doing this later on. I'm thinking that most of this is a slope. If you need a review, if you need me to slow down at all, just raise your hand or say stop. Let's use the point slope form to write an equation of a line that has a slope m and a y-intercept of 0b. So we're going to use the point slope form of a line. That's this form. And the slope is m. Okay, that's what I have. And the y-intercept is 0b. So that's an x1 and a y1 right there. So I'm going to put those values in. So y take away b is equal to the slope times x take away 0. Y take away b equals mx. Add b to both sides, and there is my slope-intercept form of a line. And that's how a lot of people think the slope-intercept form is the equation, but really it's a derivative. You derive it from the point slope form. Okay, so again, we use this letter B to represent the y-intercept, the y value, the y coordinate, right, of your y-intercept, because x is 0. And again, so this is another form of a line. So it doesn't matter if I had the same question that I had back here under, what one was this, 2A? If I had this same question, students say to me, couldn't I do that question using this form? And the answer is yes. If I said, find the equation of a line that has a slope 6, we already did this one, slope 6 and goes through, what point was it in 2A? I can't remember. And passes through what? 2 comma negative 1, okay? Oh, 2 comma negative 5, okay. So point slope, it's sitting there. It's like the point slope's like yelling at me when I read a question like this, because I have a slope and a point. I mean, why would I use anything else? But some of us are so ingrained into thinking about this formula. Let's see how we would find the exact same equation, which we found back here, y equals 6x minus 17, without using the point slope form. So let's start off with this. And the first thing you're going to put in is the 6 for m. Y equals 6x plus b. So now this is where a lot of students get stumped. They say, where do I go from here? Well, you need to find the value of b. You must find the value for b in order for this to be done. Well, how are you going to do that? Well, the only way you could solve this equation for b is if you know a value for y and a value for x. Do you know a value of y and x at a point that's on this line? Yeah, 2, negative 5. So you put in your point. Y is negative 2. Y is negative 5 and x is 2. So you throw that in and guess what? You solve for the letter b. Negative 5 equals 12 plus b. B equals negative 17. So now you have all of the information you need to know. And this is the only part where students can mess up. They solve for b and then they just leave everything like this on their paper instead of writing their final equation by putting the slope and the intercept back in and circling that. And that's the one good thing about the point slope form is it's done. When you finish it, everything's done. You don't have to plug things back in. So as you can see, It really doesn't matter. You can use both forms. You should have the flexibility of using both forms. So if your homework says use point slope, use point slope. Get used to it. If it says use slope intercept, use slope intercept. Okay? Any questions on this? All right, so here we go. Who's going to read this dramatically from me? Dramatically, because it's a dramatic statement. Nobody? Nobody's in the mood to read it dramatically today? William, you in the mood?
There's a third problem, line other than point slope, slope intercept. Seriously, another one? You've got to be kidding. General form for the equation of a line is ax plus by plus c equals 0. Luckily, this form is equivalent to the other two. Solve this equation for y. Got the slope intercept.
Okay, thank you. So, well, I won't have you solve it for y. I just want you to see what this looks like, and let's practice. Why would we want to use this form? I mentioned this form earlier. What good is it, right? Why are you clogging up my brain here, Kavanaugh? Well, this form of a line is really useful for graphing straight lines. If you have the form in general form, what you tend to do as students is part A. You tend to do part A, which is a lot of work. So I want you to do part A, and I'm going to do part B. No, you're going to do both, but let me show you why again. This form is so convenient because it lends itself to graphing if you use the x and y intercepts. So you have this equation, and it looks really funky, and you say, ugh, how am I going to use that to solve anything other than finding an x and the y and doing the whole table thing? Well, you use your intercepts. You know your two different intercepts. Take turns letting x be 0, that's your y-intercept, and then y be 0, that's your x-intercept. So look what happens when you use your intercepts. When you use your y-intercept, you let x be 0, and voila, you get 6y plus 12 is 0. You know y has to be -2. Boom, you're done. You got a point. Because you subtract 12 from both sides, y has to be -2. Similarly, you now take the same exact equation and you let y be 0. The minute you do that, this whole term here, 6y, disappears, and you get 3x plus 12 equals 0. So when you do a little 2 more steps, you get x equals -4. So now you have the point -4, 0. You're done. You've got the 2 points you need to graph that line. And it's as easy as, I don't know, whatever you find easy. Okay, you just find those 2 intercepts and you're done. I want you to compare doing that, even though I know I did it, compare doing this with what you're about to do to graph this line by putting it into, oops, this should say slope intercept form, slope intercept form. Okay. So go ahead, graph that line by putting this equation in a slope intercept and then finding some points on it. See how long it takes you. And then decide what you like to do better, what you think is the fastest, most efficient way. Into slope intercept form. So we're starting off with the general form. So what does it mean to put it into slope intercept form? What is the final form of this equation going to look like? It's going to look like, right, we want to make it equivalent to y equals mx plus b. So that's why we want to solve this equation for y. We want to get y all by itself. So you can subtract 12 from both sides if you want to start off. 3x plus 6y equals -12. And then we can subtract 3x from both sides. So we get 6y equals -3x minus 12, and we're almost done. Now to get y all by itself, we have to divide each and every term on both sides of the equation by 6. So this leads us to 1y equals -36x minus 2. And we reduce -36 to be -1/2x minus 2. So now you got your equation. It's a lot of work, and now you would still have to graph this thing. So depending on where you are, you might at least notice one point very quickly is 0, -2. And then some of you might have to put in an x and figure out a y. Some of you might feel comfortable using the recipe for slope that says, okay, to use my recipe for slope, I'm either going to walk to my left 2 and up 1, or walk to my right 2 and down 1. So you could do either one. You could walk to the right 2 and down 1, or you could walk to the left 2 and up 1, left 2 and up 1. And you're going to get exactly the same line that we got a few minutes ago. So you can determine which of these two methods you think is easier to graph a line if it's given to you in the general form. Okay? I have my own opinion on this, but you may have a different opinion. Okay, any questions on graphing the equation of a straight line if it's in general form? Using either method? Anything at all? All right, so horizontal and vertical lines are very peculiar in the sense that their equations don't look like all the other equations, okay? The other equations are in, let's say they have a form y equals mx plus b. They always have a y and an x in it. All the other lines have a y and an x in the equation. These lines do not. So students say, how am I going to remember this? How do I? And I say, don't try to memorize it. Just visualize what a horizontal line looks like. And all you have to do is just actually put in some points. -4, 3, any point on here. I don't really care which ones you pick. Okay, this is what I do in my mind. I never memorize the equations. I just literally look at a horizontal line in my mind and I say, what's true about that horizontal line? Beside the fact that it has 0 slope, what could you tell me about every point on that horizontal line? Y is always 3. If you can say it, you can write the equation. Y is always 3. You just, that's your equation right there. Y equals 3. You are done. Okay? It's a constant. Y is constant. Doesn't change. Doesn't matter what x is. It has absolutely no effect on this equation because y is always going to be 3. Similarly, you can do a same thing with your vertical line. You could just pick a couple of points, -3, 4, -3, 2, -3, -3. And you could look at those 3 points and you could say, what's true about any point on this blue vertical line? And I think we could say the same thing that Gina just said a minute ago, but we'd have to change the name of our variable and the number. So what could we say here other than Gina? What else could I say about this blue line right here? That's right, Brittany. X is always -3. And now we have our equation. X equals -3. We are done. We love coming up with the equations for vertical and horizontal lines. So the trick here is to note and try not to do too much work. If I said to you, what is the equation? Well, let me change it up a little bit for you. Because this happens a lot on a quiz or a test. Your teacher might say something like this. What's the equation for the following line? Okay? And you're just so ingrained into doing y2 minus y1 and all that, you don't even look at your points. The minute you see something like that, you say, both of my x's are the same. So there's my equation. X x is 5, right? X is 5. Similarly with this, if I gave you this, I could say -1, 6. I could say 0, 6. I could say 10, 6. If I said, find the equation of a line that goes through those points, you say, oh, wait a minute, that's one of those peculiar ones. All my y's are 6, so this is a horizontal line, y equals 6. Okay, you don't have to do all of the work that you did previously to find the equation of a line. So just keep your eyes open, be thinking, don't try to get into like a real routine here, because sometimes you can save yourself some time and energy by looking for these types of lines. Okay? Any questions on horizontal or vertical lines? Okay, we got two last types of lines to cover. They're called parallel and perpendicular lines. And the two bits of information you need to know are given to you right here. I think some of you will remember that parallel lines have slopes that are equal, and that's the easy one to remember. It's the perpendicular one that gives people a hard time. The perpendicular lines, and if you look at these pictures, Caitlin and I selected this particular picture to help you try to remember the fact that perpendicular lines have opposite reciprocal slopes. Notice, why do the slopes have to be opposite? Because when you're perpendicular, you're going in different directions. So one of your lines has to have a positive slope and one has to be negative. So the signs of these slopes will always be opposite. And then the other interesting feature is, look at the triangle formed here. For the blue line, the slope is this rise, A, divided by B over B. And then when you flip that around, what was the run here became the rise or the drop here over A. So you have a reciprocal relationship in the slopes. So if I told you that the slope of my first line, M1, was negative 2/3, and I asked you to find the slope of the line perpendicular to M1, what would be the slope of M2? Well, you say, okay, the first thing I know is it's going to be positive, and then, right, I switch my rise and run, so it's going to be 3/2. And one way you can always check is if you multiply your two slopes, you always have to come up with -1 because they're negative reciprocals of each other. Okay, so perpendicular lines have slopes that are opposite reciprocals of each other, or negative reciprocals. So try doing these two questions, A and B, at your seats, and I'll help you out. And then you have a group activity that you should have at least 15 minutes once you're done with these to complete. So I'll put on some music and use your flags to show me that you need some help or check with your table mates. So in this first one, we have an equation already given to us, and we're trying to find the equation of the line parallel to this. So if you want, you could just do a quick little sketch on the side. You know something about this line. It goes through 0, 1, and it has a slope of 3. Whoops, didn't I do a good job on that? 0, 1, right? And it goes through and has a slope of 3. So we're trying to find the line parallel to that goes through this point, -2, 5. -2, 5 is somewhere down here. Oops, somewhere up here. All right, and we're trying to find the equation for this line. I'm really bad at drawing lines today. Oh, there we go. Let's try this again. That's better. But that doesn't look parallel, does it? Oh, use your imagination. So -2, 5. So I'm trying to find the equation of that blue line. That's all it's asking me. Well, I can't find the equation of a line unless I know the slope in a point. Well, I have the point, and the slope I get from the fact that I know it's parallel to this black line. So the slope of this blue line is also 3. So I just go back and I say my slope is 3. I go through this point. Boom, I put it into my point slope. I'm all done. Okay, now if I want to put it into slope intercept, I have to do a bit of algebra with my distributive property and then solve this equation for y. And I'm done. 3x plus 11. That's the slope intercept form. Okay, this says find the slope of any line. You can't come up with an equation because I didn't tell you what point I go through. So I'm just asking what the slope of any line is that's perpendicular to this. The problem is that this is in general form. So you must convert this to slope intercept form in order to pick out the slope. So most of you were able to find that the slope of this line was -1/3. So the slope of anything perpendicular to that will be 3. You change the sign and you flip it around, 3/1. Okay. So the last thing we have to cover before you do the fray and knot exercise is the idea of slope as a rate of change. Now, I'm not going to go through all of this with you about finding the whole equation. I think we've just done that like 6 times today. What I'm more concerned about here is how to interpret the slope. So let me show you how I would approach this problem. I would read it, of course, and as I read it, I think to myself, what's my dependent variable and what's my independent variable? Well, we're talking about the price of gasoline based on time. So I know that time is going to be my independent variable, and I'm looking at 2 years here, 2000 and 2011. And it was $1.93 in 2000, and it was $3.53 here. The other thing that I do is I often will write, without any specific numbers, the units for each of my variables. So I put here years since 2000 and dollar, because those are the units for my 2 variables. So since this function is going, t is going to be measuring the years since 2000, I have to represent these 2 coordinates a little differently than what I plucked out of my sentence. I'm not going to be writing 2000 and 2011. What would I be writing instead? 0, because 2000 is 0 years from itself, and 2011 is 11 years from 2000. Okay. So now the first thing I have to do to find the equation for this line is to find the slope. And this is where you want to be a little more aware of what your actual variables are. You're not using y and x anymore. You're using t and g. Okay, so you would write here the change in gas price over the change in time. And I would, in terms of interpreting the slope, keep your units in when you calculate your slope. So you would say $3.53 take away $1.93 per gallon. All right, and there we go. That's per gallon, the price per gallon. So if you wanted to, you could put that in parentheses and even over here say per gallon. As long as you write it in the end, it doesn't matter. And then the change in time was 11 take away 0 years. So when you do your math, you get $1.60 per gallon over 11 years. Now you got to approximate this because you get 0.14. So exactly the slope would look like this, 0.14545454545 per year, right? So in order to talk about this or interpret it, we're going to estimate that this is 14.5 cents per gallon per year. So if I have all of my units in my calculation to interpret it, I say the slope tells me that every year from 2000, starting with 2000, every year my gas prices rise on average 14.5 cents per gallon. So you have to have your numbers and your units in it. So on average, my gas prices rise 14.5 cents per gallon each year. There's lots of different ways to say it. Okay, so you would use this and then go back and use your point slope form. I would use the 0. Look, you're all set. Here's your y-intercept. So I would actually, this is the one time I would use my slope intercept form because I've got my y-intercept sitting right there. And I got my slope right there. So what does my equation look like? G of t, because we're working in functions now, G of t equals 0.145 times t plus 1.93. I'm all done. I don't have any work to do. It's a lot easier in this case to use slope intercept. Okay. So read the story about the percentage of people never getting married for different ages now. It's called the fray and knot, and see if you can get at least problem 1 done, and then you have some more problems on the other side, okay, for your class activity.